Hey everyone, welcome back to Physics 11. In this video, I want to go over the question number 7 from worksheet 8.4 on electromotive force. Now this question says determine the internal resistance and the power dissipated by the internal resistance of the battery shown. Now in this case, we're given the EMF, epsilon is 18 volts, and we're trying to find the internal resistance of this battery. Now notice here that we also are given the current for this circuit. This is our I total. Right? Because you can see that this is the current that's going to flow into the battery and then come out on this side. So this is our I total. So you know your I total, which is 1.2 amps. Okay, and you know your EMF, which is 18 volt. So we're trying to find the value for the internal resistance as well as the power dissipated by that resistor, by internal resistor of the battery. So we need to first find the lowercase r. In order to do that, we need to know the total resistance, right? Now we can find the total resistance because we know the EMF, we know the current. So if you're using Ohm's law, so again, we're going to start with that, which says that voltage equals current times resistor, sorry. And we're looking for the total resistor. So R is going to be V over I. Now, in our case, we are going to be looking at the EMF. So our total is going to be the EMF over the current, the I total in this case, which is given. So we're going to have to plug in our 18 volt over the current 1.2 amps. Now this should have two sig figs as we found answer, but again, because this is an intermediate step, you want to use all of the decimals in the next step. So in this case, we don't have to worry about decimals because the answer is a rounded number. So this is going to be 15 ohm. So that's going to be a total resistance given this circuit. So the next step is to find or write down the equation for the total resistance, and then from which we can then find the value of the lowercase r. So the equation for the circuit is the following. We have two resistors, R1 and R2 in parallel, and then it's going to be in series with the internal resistor lowercase r. So we're going to write our lowercase r plus R1 in parallel to R2. That's our equation for this circuit. Now let's plug in the values, or actually let's solve this for lowercase r. So it's going to be the RT minus R1 in parallel with R2. So we know the value for our total already. We just found it to be 15 ohm. Well, these two we just need to add in parallel. So we can plug in the value for our total is 15 minus, I'm going to open parentheses here. Now these two are in parallel, so you had to be careful with this. You had to do 1 over, so it's going to be 1 over 20 for R1 plus 1 over 30 for R2, and then you had to reciprocate it, so you're going to take the reciprocal afterwards. So once you do that, and you can use your calculator for this, so it's going to be 1 over 20 plus 1 over 30, which is 1 over 12, which once you reciprocate 1 over 12, it's going to be 12, so we end up with 15 minus 12. So the answer here is going to be 3. So that's going to be our internal resistance lowercase r. So that's the first part of the question. Now the next part of the question is to find the power dissipated by internal resistance of the battery. So remember, power can be written down in 3 different ways. So in this case, we're going to use the equation for power as power equals I squared times R. Now the reason we want to do this because we want to find the power through the resistor lowercase r. So we don't need to know, like I said, there's 3. So this is the first definition, right? Current times voltage. Now that would be too much work finding the voltage across the R if you already know the lowercase r. So this would be the quicker way. So from here, from this equation, we can just find the power dissipated by the resistor We know the total current already. So the current is going to be 1.2 amps. 1.2. Now we need to square this times the lowercase r, which is 3 ohm. So in our case, we're going to be using the lowercase r here, times 3 to find the power dissipated by this internal resistance. So let's see what that is. So 1.2 squared is 1.44 times 3 is 4.32 watts. So that's going to be the power dissipated by that internal resistance.